Okay, I want to show you the celestial sphere before I show you how to use the telescope. So let's say this is Earth, right here in the middle. It's not very good, but imagine that's a perfect circle. There's the North Pole, and there's the South Pole, and then there's the equator. Okay, so imagine this in 3 dimensions, like a three-dimensional globe. So if we look out into the night sky, we see all the stars in the sky. You know, if we look any direction, we see all these stars. And to us, it looks like they're all kind of the same distance. Some stars are bigger, some are smaller, some are brighter, some are less bright. The reality is the stars are all sorts of distances from us. But to us, it just looks like they're kind of like on a sphere in the sky. Imagine that sphere, imagine that sphere going all the way around. I'm really bad at drawing circles. Um, so if we look out anywhere on Earth and we see all these stars out here, we can't tell how far away they are, but it just looks like they're kind of imprinted on the night sky. So this is called the celestial sphere, and it encompasses the Earth in 3 dimensions. So imagine it, going this way too, and then underneath as well. Okay. Now, if we were to extend the equator out across this sphere, it would, I should probably do a different color, but imagine this in 3 dimensions. So if this equator were to spread out and touch the surface, inside surface of this sphere, then this is called the celestial equator. So there's Earth's equator, and then there's the celestial equator. This is the celestial sphere. Now we can't see any of the stars on the southern half of that celestial sphere. We can only see what's from the celestial equator north, because we're in the northern hemisphere. So if you live in the northern hemisphere, let's say you're there. So you're only going to be able to see what's on this top part of the sphere up here, all this stuff. And that's called the celestial dome. So we have the celestial equator, the celestial dome, which is half of the sphere, and then the entire celestial sphere. But we can't see anything from this down because we're only be able to see what's up here. Okay, so I redrew it in different colors. So there's Earth, there's the Earth's equator, there is our celestial equator, there's the celestial sphere, and on that is where we see all our stars. Now remember, this is north and this is south, like that. Now here is the North Star. It's called Polaris. Polaris. That's the North Star. And it is directly overhead from the North Pole, or the axis of Earth, more or less. It's pretty close. So imagine this is a flat surface here. This whole thing is like a flat surface that extends out from the equator. So underneath here we don't see, so we're just gonna think that this is on top. And let's say there's like a star here. So if you're here on Earth and you're looking up at that star, this is across the plane right there, and it touches the outside of the sphere. And you can see here that this is an angle that you're looking up. So this is flat, straight across from the equator, across the celestial equator. And then you're looking up a certain number of degrees to look up. So the up down that you have to move the telescope is called the declination. Let's see where I can write it. Okay, it's called the declination. So the declination is the angle above or below, we'll just say above, the celestial equator. So that's declination. How high you have to go above the celestial equator, and also below, but we'll just say above for now. So let's say you find a planet or a star or some other object in space that's right on the celestial equator, let's say you see a star right there, and remember that's on that celestial sphere, that declination is 0 degrees. The North Star, Polaris, is at 90 degrees. And then you can have everything in between 0 and 90 degrees. And that's basically your telescope moving up and down. If you go up, 10 degrees, let's say this star right here is, I don't know, that looks like maybe 30 degrees, let's just say. So you would adjust your telescope up 30 degrees, which I'll show you in another video how to do that. But I just want to explain how this works. Okay, so now we have declination, but then if you want to, so that's up and down with your telescope, but if you want to go left or right with the telescope, that's called right ascension. So I'll write that, right ascension, like that, okay? And the 0 point for right ascension is a little complicated, but basically all you really need to know is the right ascension moves your telescope so you can go around this celestial equator, like this. And then your declination is going up and down on it. So that's good for now. I was gonna add more to it, but I thought I might just stop it here so that you can go over this if you want. So we have the Earth, the Earth's equator, the North Pole, South Pole. If you extend that equator all the way out, this is the celestial sphere. That's a total sphere around the entire Earth in 3 dimensions. If we extend the equator out along the inside surface of that sphere, that would be the celestial equator, which for you, if you look at, it would literally be the horizon to you from your eyesight, basically. So think of that as the celestial equator. Now, if you want to go up, that's called declination. If you want to go down, that's declination. And it goes from 0 degrees, which is right on the horizon, we'll say. It's actually technically right on the equator's horizon, but for simplicity's sake, we'll just say right on the horizon. And then you can go all the way up to 90 degrees max, which is directly overhead, which is the North Star, which is called Polaris. And if you want to go left and right, that's called right ascension. So I hope that made sense.